That's the definition formula. What do you understand? Physical meaning?
That the speed of light in the reference medium by the speed of light in the particular medium.
Vacuum. Okay, the medium. That's the same thing here. If I say yes, medium to what property? Why the? What is the property?
Yes, speed of light in that medium.
Yes. It is a property of the medium to allow the light. That's very simple. Property of the medium to allow the light. Suppose I am opposing the light. Automatically, what about the speed? Decreases. Now what happened? I am just allowing. Means I am also helping to move. Speed will increase. That's not over. So refractive index we can write in different way. One in terms of speed, in terms of I and R, in terms of wavelength also. How the wavelength will come here? How the wavelength will come? Lambda by lambda. You can try. This relation you read in class 9th. I think the chapter name is sound. I think most probably sound. B equal to
New lambda.
huh?
New lambda.
New lambda. Okay. What is mu? Okay, can I get? Okay, no problem. Mu frequency, correct? Mu is the frequency. Yes. Same relation here also we are using. When the light travels from one medium to another medium, speed changes. The speed changes means wavelength also changes. But the ratio remains constant. That's right. The frequency remains constant. So, whenever light ray travels from one medium to another medium, now listen. Speed changes, wavelength changes, but frequency remains constant. Then you can ask this question, sir, then frequency depends on what? The frequency depends on nature of source of light. Suppose you are getting sunlight, the frequency average you take. Suppose you are using sodium vapor lamp, frequency of sodium vapor light. It will not change when you travel through any media, different media. But which one will change? Speed will change, wavelength will change, but no change in the frequency. No change in the frequency. Yes. Why? Why the frequency? Because the frequency is nothing but in the sound. What is meant by frequency?
The number of times.
Number of times the vibration takes place with respect to time. Okay, so that is the source of wave. The source of wave is nothing but disturbance. The same thing light also. It is nothing but disturbance. So what is the source? Sun is the source. So source we are not going to do anything. Suppose sodium vapor lamp using. The source of light is sodium vapor lamp. So if you want to change, you have to change the origin of the light. From where the light is produced. Suppose you want to change, the light is having some frequency. Suppose here air is there, I am giving glass. Because of that, no change in the frequency. Now I want to change the frequency, I have to change the source. Because the frequency started from the wave. So that's why V changes, lambda changes. V increases, lambda increases. The concept is clear? Yes. So what will come here? Lambda A, L, that's the same one. V1 by V2 equal to lambda 1 by lambda 2. The formula is clear now? Yes. So now you are understanding the deviation to yes. Wavelength which light? Okay, just leave the question, sir. Sir, next one. I'm going to explain. Okay. You will be getting answer now. Now, this table, no, you don't try to remember. Just to make some observation, that's all. You see, I have taken here up to diamond. You tell me which is optically denser comparatively? Diamond. Because it is a 2.4. Optically rare, least one. Air or vacuum. When I talk about medium here, one thing all of you understand, how much light passes through vacuum, how much light passes through air, it is almost same. That's why I have written here vacuum. But it is not a vacuum substance, but compared to speed, it is almost the same. Because exactly number if you want to write, you have to write 1.001 something for air. For vacuum, you have to write 1. How? N equal to C by V. N equal to C by V. C by V. Now suppose if I take vacuum, what I will do? Speed of light in vacuum. Okay, suppose X. Next is same I have to take. Speed of light in vacuum. How much? X. How much? 1. 1. Now if I want to take air, refractive index of air, speed of light in vacuum 3 into 10 power 8. Speed of light in air. But what you assume? Slightly less. Vacuum, highest speed. Once you come to the medium, so slightly less. Slightly less means, what about this value? Greater than 1. But for practical purpose, we take for air it is 1. The same property, same comparison we are doing for electric field and magnetic field also. There also what we take, how the magnetic field is allowed through vacuum, same we take for air. How the electric field, the same thing. Okay. So what different? One is medium, another one is free space. But as per the permission to allow the light, allow the electric field, allow the magnetic field, almost same. The concept is clear? The next one. Just wait. Yes. Now you see, here how much you are getting? 1. What is the speed? 3 into 10 power 8. Okay. Now angle of refraction, if the incident ray enters 20 degree. Suppose 20 degree means it is almost the same you are taking. Now come to water. Water 1.33. So here you have speed. Speed is reduced. Speed is reduced means what about here? The angle of refraction? Reduced. Reduced. Because bending towards the normal. Now where you have more bending here? 8.2. Imagine. What you are supposed to have? 20. From 20, how much it is reduced? It comes to 8.2. Now you are understanding why the bending takes place. So which is having higher refractive index will have more power to bend the light ray. So refractive index is nothing but what? Property to bend the light ray. More bending, more refractive index. No bending, The medium is nothing but
Vacuum air.
very good. Homogeneous medium. That's all. Next. Yes. Now in the refraction, what is happening? See, this is the actual, you are able to see the pencil, this is the actual position here. Now what is happening? Here it is little, each point is raised. Why it is raised? Because of refraction of light through water. Refraction of light through water. Suppose here you have the object. So whenever you want to get the image, always take the light ray from the object. So one ray I am taking straight. Where it will go? It will go as it is. Now another ray I am taking from here. One ray.